Good afternoon and welcome to the session 2 of TSDSI Technical Deep Dive 2023 conference. This session is on advancing ubiquitous connectivity through convergence. And we thank One Media for sponsoring this session. My name is Akash Malik and I am the coordinator. And before we move ahead, I'd like to remind you of some quick points about this session. All attendees will be kept on mute. And welcome to the session 2 of TSDSI Technical Deep Dive. Throughout the session by default. If you have any questions for speakers, please type them in Q&A tab. Questions to the speakers posted in the chat box will not be entertained. You may interact with fellow attendees live using the chats tab during the session. If you want to enlarge your presentation, please click the expanding arrow icon on the top right of the presenting screen. The tool is configured for HD video. You may switch to low definition or LD in case you are facing bandwidth problems. This webinar is being recorded and will be posted to the TSDSI website within the next few days. Attendees may like to visit the exhibit booth of TSDSI in between the sessions to know more about our work. Attendees can use the lounge facility for networking. The lounge will remain open till the end of the conference. Now I'd like to introduce you to Mr. Guna, who will be moderating this session. Mr. Guna B. Shekhar is a telecom storage and networking professional with a VLSI design background. He is currently consulting part-time with TSDSI. Over to you, sir.
Thank you, Akash. Appreciate the introduction. So welcome, everyone. I'm very excited to be the convener for the session today. We have a packed agenda with a great set of speakers. I think we're going to completely enjoy it. So let me start with giving a quick overview of the agenda today. We'll start with opening remarks by our co-chair Mahesh, and then followed up with a keynote from Satish from Reliance Jio, and followed by another keynote, importance of broadcast and convergence by Madeline, who's actually dialing in from the US. Thank you, Madeline. It's kind of early for you. Then followed by a panel discussion, which will have a pretty interesting topic there. Is really about, we're talking about connecting the unconnected in India, but what is real and what is not, right? So we'll get into some pretty interesting discussions there, but we'll have a great set of panelists. And then we'll close it with some closing remarks by Avinash. Okay, let's go to the, with that, let me introduce our session co-chairs. Avinash Agarwal, TEC. I'm very happy to introduce Avinash here. Avinash Agarwal is an ITS officer of the 1992 batch. Presently, he is posted as Deputy Director General, Convergence and Broadcasting at TEC, India's standard-setting organization. So welcome, Avinash. Thanks for all your help. Our other co-chair is Mahesh Nayaka. Many of you are probably already familiar with Mahesh because he's very active in TSDSA activities. Mr. Mahesh Nayaka Mysore Anaya is an Assistant Vice President, Global Standardization Team at Reliance Jio Infocom Limited. He is currently serving as a chair, Services and Solutions Study Group in TSDSI. Thank you, Mahesh, and we appreciate your time for being the co-chair of this session. So having said that, so let me invite Mahesh to give his opening remarks to kick the session off. Thank you.
Thanks, Guna, for a quick introduction. Good evening, everybody. Good morning. Thank you very much for giving me an opportunity to co-chair this particular session along with co-chair Avinash Agarwal. The topic of the session is on advancing ubiquitous connectivity through convergence. Actually, everybody is aware of the term ubiquitous. Ubiquitous is basically a present or available everywhere. But ubiquitous connectivity means it's something like the connectivity available everywhere doesn't make sense basically. Basically, it means that it allows the end user to have connectivity everywhere at any time, at any place, and through any device basically. So this is one of the key usage scenario in IMT 2030, that is 6G. And this particular usage scenario is basically intends to provide uninterrupted connectivity for anyone and anything through hybrid terrestrial and non-terrestrial networks. So basically, the intention is to interconnect the space communication, air communication, ground communication, and sea communication together to provide 3G coverage and connectivity to all forms of territory and space, permitting communication at any time or location. So, does that mean that today are we 100% okay from the connectivity perspective? See, though we have evolved from right from 1G till 5G as of today, uh, from the connectivity point of view, we are not 100% perfect. For example, see, when we have a call and enter into a lift, when the lift starts moving across the floors, our communication gets interrupted. That means it is as good as having a coverage hole within the lift as well. Suppose when we get dropped by a cab driver in the hotel or in any office and ask the cab driver to wait for some time, he is forced to park the vehicle in the basement parking. So the driver actually rejects to park his vehicle in the basement, not because the basement scenario is bad, but he has got only two options to do in the basement: either to sleep or to enjoy the multimedia services. But to enjoy the multimedia services, he needs to have a coverage. But normally in the basement parking, coverage will not be there. So he prefers to stay outside. So the problem is the coverage hole. The coverage hole is predominant in the basement area. In my house itself, if I go behind my house, I will not get the coverage. And also in some of the rooms, if I go to certain corners, I will not get the coverage. So this is the scenario. Even though we are in the densely urban or suburban kind of deployment scenarios. And also, whenever I am boarding a flight, there will be a formal message telling that we have to go to the silence mode, just to ensure that it will not interrupt the flight operations. So it is indirectly says that we are entering into the coverage hole until flight takes off or flight lands. So we are in the coverage area. And even if we go to when the fisherman goes for fishing in the deep sea, he will not be able to communicate. It is as good as he entering into the coverage hole. So basically, what I mean to say is, even though we are into the 5G technology as of today, there are a lot of times where our call gets suddenly dropped. So when we say suddenly dropped, it means that we are in the coverage hole. Even though we have enabled handover scenarios like hard handover, softer handover, lossless handover, seamless handover, forced handover, we are still facing call drops at certain times. May not be frequently, but of course we are experiencing this. And another issue is, whenever we try to call a person, sometimes we'll get a message telling that the dialed person is out of coverage area or not reachable. And as a value added service, we will get the message later point of time telling that the dialed number is now available to take the calls. So these kind of scenarios indicates that there are certain coverage holes even in the urban and dense urban kind of areas. Forget about rural areas and remote areas where the terrestrial kind of communication networks is not able to provide coverage or services. So for that we need to embrace a non-terrestrial kind of service. So, having said all these issues, it is not a smooth ride from today's connectivity to the ubiquitous connectivity of IMT 2030. So, a lot of challenges that needs to be addressed as part of ubiquitous connectivity in 6G. So basically, the some of the examples of ubiquitous connectivity, what we are foreseeing is connecting the remote or rural areas, then connecting the scenarios like when people are traveling in the aeroplane or when people are people are traveling on the boats or in the cruise, there should be uninterrupted connectivity from the terrestrial to non-terrestrial and vice versa. And also the another important point is when we want to actually realize the ubiquitous connectivity, there should be a quality of service which has to be maintained across all the RITs. And also the security has to be ubiquitous. That means the same level of security should be there across all the involved RITs so that there will not be any risk. Having said all these things, ubiquitous connectivity is definitely going to interconnect space, air, ground, sea together to ensure that the user gets connected at any place, anytime, and through any device. So instead of taking more time, let us hear from industry experts about their views about ubiquitous connectivity and the realization in IMT 2030. And I will stop at this point. Over to you, Guna sir.
Thank you, Mahesh sir. That was definitely excellent way to set the context here, and it's very eye-opening. And thank you for setting the context in such simple language and simple examples. I really enjoyed it. So thank you. So now let's go to the next slide, Akash. So I'm really excited to about our first keynote topic today, and this is by Satish, Ubiquitous Connectivity for 6G. So he's going to get into a pretty exciting topic here. And let me introduce Satish. So Satish is no stranger. If you have been involved in 3GPP or TSDSI or any of this, he's quite a prominent figure. So Satish Jamadagini is currently the Senior Vice President and Head of Global Standards at Reliance Jio. He has 23 years of industry experience in the telecom domain, and he's also the ex-vice chair of TSDSI, which all of you are quite familiar with. So he's quite active in all the standardization activities, and he's also a prolific inventor. You can see that he's got about 200 granted patents. I mean, that's quite a bit. So thank you, Satish, and we are extremely happy that you're going to do the first keynote. Over to you, please. Thanks. Can we bring Satish on?
Thank you. Can you hear me?
Yeah, yes, we can. Yeah, please go ahead.
Okay. Good evening, good morning. So I'll be talking about ubiquitous connectivity. There's been quite a bit of discussion on this, especially in IMT 2030. The ITU discussions leading to IMT 2030. This was one of the contested usage scenarios, primarily because what is ubiquitous connectivity? I mean, this is hello. Yeah, so there's a certain amount of subjectivity to the whole question. So whether you achieve ubiquitous connectivity through deployment scenarios, whether you really need different technologies to achieve ubiquitous connectivity, that's one of the key questions. So, but anyway, ubiquitous connectivity has made it into the IMT 2030 vision document. So that's where we stand. So, can we go to the next slide, Akash? So much of this focus on human-to-human connectivity has already been addressed, or it's going to be continuously addressed in whatever ways, primarily deployment scenarios and other such issues. But then technologies exist. So it's a matter of shelling out more bucks to achieve connectivity through multiple mechanisms. And there are multiple ways and means of having connectivity in so-called places where you don't get connectivity. But what do we mean by ubiquity going forward, especially with 6G, primarily which concerns machine connectivity? We have multiple IoT standards, way too many standards. There's been a bit of fragmentation, because of which there's way too much of proprietary standards which are popping up in the name of IoT standards. So one of the key things that we see is it's some kind of a disappointment as far as IoT standards are concerned. There are quite a few standards, and a body like 3GPP, when it supports or when it cooks up a standard, should be in a position to support it fully. There are certain standards which are preferred on top of others for whatever reasons. But certain geographies accept certain standards and others don't, for whatever reasons. These are issues which will have to be discussed, and that's one of the key things that will have to be addressed as part of the 6G standardization, so-called globally harmonized standards. Else, there is always a chance that you have proprietary standards which are coming out from different geographies. That's bound to happen. But anyway, the emphasis here is on machine connectivity. When we talk of ubiquity, and that's one of the key focus areas. 3GPP is also working on something called as RedCap, which is the same category as LTE devices for all practical purposes. And the assumption is someday when you take down LTE networks, then this is some kind of a replacement for LTE networks. But it will be interesting to see if 5G goes down before LTE goes down. So will we ever see 5G RedCap deployed anywhere? Of course, in some pockets, maybe. But wide area deployments, will it see wide area deployment? Is questionable, but we'll leave it at that. So in general, the key takeaway is the major focus of ubiquitous connectivity will be on machine connectivity, not so much on human-to-human connectivity, but of course there is a factor. It's a factor of 80-20, 20% of human connectivity and 80% of the focus will be on machine connectivity. Can we go to the next slide, Akash? So what is happening, at least within 3GPP, as far as overall connectivity is concerned? One has to understand connectivity is not necessarily just EMBB. It can also be broadcast. It, of course, covers IoT. It, of course, covers non-terrestrial connectivity. A whole sort of disparate technologies will have to come together to broadly address ubiquitous connectivity. But what's happening in 3GPP? Ambient IoT is one of the specifications which is it's in the cooking. What does ambient IoT mean? Primarily addressing sensor devices or devices which can harvest energy, which can exist on backscattered power sources and not necessarily have a power source. This is primarily intended at IoT segment again, and this is one of the key areas where much of energy is being invested as far as 3GPP is concerned. This is one part of ubiquity. And much of the standards are expected to come only in 6G, though much of studies are being done as part of 5G advanced or whatever releases which are coming currently. Next slide, Akash. So broadly, the notion of ubiquitous connectivity is well understood. Connectivity by any means. Satellite, space networks, you have aerial networks, you of course have terrestrial networks. So all of that is coming together. Anyway, 3GPP has the non-terrestrial network specification, the base specification, which is in place today. Of course, the specification will have to grow beyond a certain breaking point. That's when it will see mass deployments. So it is expected to see mass deployments by 2030, and that's more or less the 6G timeframe. But when we look at all of these different modes of ubiquitous connectivity, there is one thing that we observe. Can we go to the next slide? There is one thing which comes out very clearly. You have a bunch of disparate means to connect And all of the disparate means to connect does not necessarily have to have the same air interface, the same protocols, the same application scenarios, the same network architecture. So all of them can evolve in different network architectures, different air interfaces, uh, and that is something that has to be very clearly observed. And irrespective of what is happening as part of the mainstream specification work, this is something which is already evident. Your IoT air interface nature of the protocols is very different. Forget about 3GPP for a minute. Even if you take some of these proprietary IoT technologies, which are supposed to be very optimal for the given task, that is the case. You have LoRa, which is also expanding as an IoT alternative. If you look at broadcast is also one of the key technologies to reach remote corners, maybe one way, but still is a means of connectivity. And if you look at different standards which exist today for broadcast, the 3GPP broadcast versus, say, for example, ATSC 3.0. The air interface of ATSC 3.0 is at least said to be more specialized for broadcast, optimized for broadcast. In that sense, I mean, of course, there's a lot of discussion happening about ATSC 3.0 and FEMBMS 3GPP technology for broadcast. But anyway, whatever the key point here to understand is ubiquitous connectivity will bring a host of connectivity solutions, every single one of them with their own air interface specialities, their own protocol specialities, their own application scenarios, may not and will not have to be under the umbrella of one single air interface, one single network architecture, one single application set of use cases or set of APIs opened up into application space. That is very, very critical. That has to be understood. And that opens up the question of how we go about designing 6G and how we go about designing for ubiquitous connectivity in 6G. That is the key thing that is the key thing that has to be understood very well. What is left out, what is not still in the popular debate as far as ubiquitous connectivity is concerned, smart spaces, that's one of the key areas which will not be explored. Not much of work happening, at least in 3GPP in this direction. But again, I mean, there are multiple standards organizations where this can be addressed. So this is one key area which is yet to be explored to plug the gap of what we call as a suite of connectivity technologies which will cater to ubiquitous connectivity. Then, next slide. So in summary, what are the key challenges for ubiquitous connectivity? One is we have to understand that ubiquitous connectivity is a whole bunch of basket of technologies. It'll come with a basket of technologies. You have IoT, you have non-terrestrial networks, you have drones, you have HAPS, high altitude, whatever technologies. You have broadcast, and you have different nature of services even within a so-called IoT space. It can be something as simple as a sensor network versus high-resolution cameras which are connected through IoT network. So all of these disparate mechanisms of connectivity will have to be addressed, not necessarily under the grab of one single air interface, one single network. It will have to be different, and it will be different in my understanding as far as 6G is concerned. So the key challenge is one may have disparate or whole bunch of technologies in place, but for an operator, I mean, speaking on behalf of the operator, one will have to also have mechanisms of aggregating all of these technologies into some kind of a manageable composition. And that's one of the reasons why even in ITU, IMT 2030, we have been emphasizing or focusing on what is called as composability as a key mechanism to bring all of these connectivity mechanisms into a single bucket or manageable bucket. So this is the key thing that has to be understood as far as ubiquitous connectivity is concerned. So it may mean disparate technologies, it may mean disparate air interfaces. That's all fine, but as long as we have a mechanism of bringing all of these under a bucket of, a system of cloud or whatever we call that as a 6G system, that's still fine. I mean, that's the way it has to be. So this is the key message that I just wanted to deliver as far as ubiquitous connectivity for 6G is concerned. 6G connectivity is going to be drastically different from what we understand under the grab of 5G connectivity. And it's good. The industry will have to scale up. The standardization bodies will have to scale up to address some of these challenges. And that's where we stand as far as ubiquitous connectivity is concerned. That's one of the, and just to summarize, ubiquitous connectivity will force standardization bodies to really rethink the way network architecture is designed and developed. And with that statement, I'll end my talk. Up for questions.
Thank you, Satish. That was crisp and up to the point, and you sort of put the I guess you put the crystal ball in front of you and peered into what 6G is going to do. So we have some time. So let me ask you a couple of questions, and then I think there's some questions in the audience too. Hopefully, you can take it up. So from an operator perspective, right? So we have before we go into 6G, which is ubiquitous connectivity, and 5G itself is like 3GPP is started working on it, which is great. Now there are a lot of if you see mobile operators and satellite operators around all over the world, they're all in discussions, collaborations, and everything, right? So we don't hear much about that from an India perspective. We don't have to get into actual names and all that. But how do you see the partnerships between the satellite providers and the mobile operators evolving from an India perspective? Do you have any thoughts on that, or is it? Or you don't have to if you don't want to, but
no, most of the operators have already invested into satellite assets.
Okay.
One way or another. I don't want to name operators, but then you obviously know most of the operators in India have invested in or spun off companies which are satellite companies. So that convergence is already happening. And there is also quite a bit of representation as far as spectrum management is concerned, where at some point in time, the terrestrial and non-terrestrial spectrum, especially when it is used for broader connectivity issues under the grab of IMT 2030, will have to be treated equitably. What that means is, of course, the regulators will have to take a call on that. It's not for us to say anything. But then it has to head in some direction. In some sense, it has to head in that direction. And what is a non-terrestrial network? Is a means of connectivity. And I don't think any operator has too much to say about it. It's just another means of business. That's it at the end of the day. So that's also providing connectivity to you, which is perfectly fine. If it meets its purpose, and it has its niche market as well. It's not like one will eat the other or something. Terrestrial will have its space. Non-terrestrial will have its space.
Got it. So I think there are plenty of interesting dynamics that are going to come into play. I think it remains to be seen, and we'll probably get into some of those aspects in probably in the panel discussion, probably. So, but it's definitely nice to see your perspective on how ubiquitous connectivity is going to evolve from a 6G perspective, because it's still it's still a framework being developed, and your points about how the architecture and the networks are going to be completely different is well taken. It's just fascinating. So and let me quickly take a question from the audience since we have some time here. So I have a question from Bindu actually. So what's the stat of TSTSI for spectrum allocation in FR2 for the coexistence of terrestrial and non-terrestrial networks? From IIT Kharagpur, Santosh Reddy.
Even in the millimeter wave, the spectrum is different. What is used for satellites and what is used for so-called terrestrial connectivity, they are different. And they are handled differently currently. And that's where it is right now.
Correct.
I don't want to comment too much on that. But yeah, There's always coexistence studies which are done before any spectrum decisions are taken by the regulator. But of course, at the end of the day, the regulator is the one, the national regulator is the one who takes a call on what gets allocated respect to terrestrial versus non-terrestrial.
Got it. So hopefully that answers your question, Santosh. I think maybe if you have to double click on it, maybe he's referring to sharing spectrum and challenges associated with it from a regulatory perspective, because and interference from a technology perspective, right? Maybe that's what is referring. I don't know. So I'm guessing.
Spectrum sharing in the terrestrial versus non-terrestrial case is not very obvious, but where it is obvious is in the IoT segment. But that's something which is, again, part of 6G. It's a different subject altogether. We don't want to confuse that here.
Okay, perfect. Any other? If there are no other questions, we can probably go to the next one. Thank you, Satish. Definitely appreciate your insights, especially into 6G and ubiquitous connectivity, and that was definitely insightful. Thank you very much.
Thank you.
So moving on to our second keynote, I'm very excited about this topic. It is so Madeline is joining us from. Madeline is the president of ATSC, and she's joining us from the East Coast in the US. Let's go to the next slide. Let me do a quick introduction to her. So Madeline Nolan is the president of ATSC Inc., widely respected for her consensus building leadership style. She chaired the ATSC technology group that oversees the ATSC 3.0 next generation broadcast standard before being named ATSC president in May 2019. So previously, she chaired various ATSC 3.0 related specialist groups, ad hoc groups, and implementation teams since 2012. She's a 20-year industry veteran. She has held key technology management and standardization roles at Bachchan Media, TELUS Group, and LG Electronics. So welcome, Madeline, and thank you for staying up so late, and we definitely appreciate your insights. Over to you, Akash. Can you come on video, Madeline, please?
I have turned on my video. Can you see me?
Yes, we can see you. Thank you.
Okay, wonderful. And sounds like the audio is okay.
Yes, it is.
Well, thank you very much for that kind introduction, and thank you for giving me this opportunity to speak to this wonderful group in this conference. So, as you mentioned, my name is Madeline Nolan, President of Advanced Television Systems Committee, and I'd like to thank the organizers of the 2023 TSDSI Deep Dive Conference, 6G Horizons, Converging Technologies for a Connected World. ATSC is actually a new member of TSDSI, and I'm honored to be before you to speak today on this important topic. ATSC is a member-supported organization which defines technologies for digital terrestrial broadcasting. Traditionally, our members have focused on digital television services, but with the introduction of the IP-based ATSC 3.0 system, broadcasters are now also focused on datacasting services and convergence with other IP networks such as 5G, LTE, LTE-based 5G broadcast, and eventually, of course, 6G. ATSC 3.0 is the world's state-of-the-art digital terrestrial broadcasting system. No other system comes closer to the theoretical limit of the amount of data that can be carried by a DTT system. It is the collected and collaborative effort of our members, from device makers to broadcasters, from technology providers to networks, and every aspect of broadcasting in between, that bring this system to life. And we're especially excited to be joining the ranks of TSDSI membership, where we hope to contribute and learn from a broad range of experts in TSDSI. One other point about this slide is that ATSC is an international organization. Our members hail from all over the world, and a growing number of countries and regions are expressing interest in the ATSC 3.0 technology, from Brazil to India, from Ghana to Guyana. But the details of what this means and how to achieve a particular set of goals varies widely. Every region has its own unique set of use cases and key technical requirements, including direct-to-mobile services, emergency preparedness, bridging the digital divide, and fostering communities through ubiquitous distribution of culturally relevant content and services. Next slide, please. And we can step through this animation. These are just some of the main points of key advancements in TV in 3.0. As part of this conference on convergence, this session on convergence, I'd like to underscore the reason why broadcast is being considered in this conversation. Next slide, please. Here we see the theoretical limit of efficiency for sending data versus how strong the signal can be. As you can see from this slide, we have the opportunity to choose least data or more data on the y-axis and most robust or least robust signals on the x-axis. And what I think is important to show here is how close the next generation digital terrestrial second generation systems are to the theoretical limit of what's possible for sending data. Next slide, please. South Korea launched commercial services of ATSC 3.0 in 2017, and signals now reach over 80% of the population of the country. Next slide, please. In the United States, the voluntary rollout of NextGen TV is now covering 65% of households across some 70 markets. New York City, which is the largest US market, is preparing to launch this month, October 2023, and that'll bring that number to 71% of households reached. It's a difficult launch process for the United States. Next year, early, we hope to have Chicago, which will be the last large market except for San Diego. San Diego is more complicated because of its proximity to the Mexican border. But by then, we will be having more than 75% coverage in the United States also. Next slide, please. ATSC 3.0 has been launched in Jamaica, in the major cities there. They are continuing their launch and hope to have island-wide services within 1 year. Next slide, please. Trinidad and Tobago has committed to launching, and they are beginning their transition this year and expect to complete in 2026. If they achieve that goal, they will probably be the first country to have completed the transition all the way through. Next slide, please. Brazil has selected key ATSC 3.0 technologies for their new DTT system, which they're calling TV 3.0. They have selected the ATSC 3.0 transport and signaling system, audio, captions, and emergency messaging. They are still testing the physical air systems, and I'm very pleased to say that ATSC 3.0 was just named one of 2 systems to advance to the final field testing. Their ultimate selection is expected in April 2024, and services will launch in 2025 per presidential executive order to complete the work in 2024 and begin rolling out in 2025. Next slide, please. India has experimental transmissions on the air today in Delhi, with the primary goal of direct-to-mobile broadcasting. Currently, there's a multi-transmitter single-frequency network with plans to expand that network. Next slide, please. And Canada also has experimental transmissions on the air today using a 3-transmitter single-frequency network for research purposes. Among their public-private partnership efforts is support for the city of Calgary, which is focusing on smart city use cases, particularly emergency messaging in public spaces and distance education in rural areas. Next slide. I'd like to put ATSC 1.0 in perspective for a minute. Historically, broadcasting technologies have advanced intermittently, so there would be a long period of time when there's no changes to the standard. And now these things have changed. This is no longer the case. In recent years, broadcast technologies have been advancing at a pace comparable to industries commonly thought to be at the forefront of technological advances, such as wireless broadband. So what is missing? What is missing is the efficiencies of the global convergence in wireless and broadband technologies. The broadcast environment has changed dramatically in recent years. the emergence of global data networks capable of carrying video services, and the emergence of heterogeneous data delivery network ecosystems are major forces of change. Decisions in the past World Radio Communications Conference meetings have resulted in a spectrum reduction for broadcasting, and broadcasters are preparing for Work 2023 to avoid similar results in some regions. The worldwide adoption of Internet Protocol services and the resulting proliferation of video streaming has made practically any data service into a video service. And the IP backbone of new broadcast systems is turning practically any video service into a data service. These two service models were once very much siloed, and now they're very much converging. There's also evidence of the increasing importance of a heterogeneous network of interworking data delivery systems, which is what this panel and session is all about. Think about the seamless use of Wi-Fi and cellular systems in smartphones. I wonder how much of the cellular spectrum capacity is saved by data that traverses the Wi-Fi networks when they're available. Amid these changes, broadcasters worldwide share a common underlying theme. The use of the, quote, public airwaves must provide demonstrable public benefit in exchange for licensed access to spectrum. Broadcasters have historically been a central member of local communities. Relationships with government, education, enterprise, and other community organizations puts them in a special place regarding how people learn about, discuss, and resolve issues that impact their communities. So what is the role of traditional broadcasters in this new world order of datacasting and network convergence? So I'm here to talk about broadcasting's important and unique role to play in the new network of networks. First, over 82% of the world's population is within reach of a DTT signal. Second, DTT is an extremely resilient infrastructure in the face of natural disasters. Third, broadcast is the most efficient way to get large amounts of data to virtually unlimited numbers of receivers. And fourth, and this is for the engineers among our audience, broadcasting is changing technically to meet these new opportunities. Next slide, please. 82% of the world's population is within reach of a DTT signal. That's 6.5 billion people served by broadcasters who see their mission as enhancing the lives of the public they serve. We should not allow this infrastructure to fall behind technically. Modernizing these systems maintains this public service as a viable commercial offering, as well as public offering that carries attractive services for the people. In addition, broadcasters share a common infrastructure design largely anchored by high-power, high-tower transmission facilities. This infrastructure is often the most resilient, designed to withstand natural disasters so that information can be transmitted when it is most needed. During a disaster, both power and connectivity need to be maintained. Compared to a cellular network of densely packed lower towers, high-power, high-tower networks have fewer towers, making it more practical to harden the towers against disaster. And in many instances, the high-power, high-tower sites have backup power generation, and microwave links are often the data connection source. With backup power and essentially a fully wireless transmission system from the studio to the tower to the home, the high-power, high-tower structures are built for resiliency. And this high-power, high-tower design, and indeed broadcasting in general, is also a highly sustainable way to deliver large amounts of data to many receivers. With the ever-increasing need for data in our digital world, broadcasting can play an important role as people seek to reduce energy consumption in all aspects of industry. To illustrate this point, this slide shows a recent study that showed that the energy consumption and associated emissions of DTT are an order of magnitude lower than estimates for OTT and managed IPTV services. These points alone, public service as a core mission, resilient infrastructure for emergency messaging, and efficient, sustainable data and video delivery, underscore the place of broadcasting in the converged world of data delivery networks. So if we agree that broadcasting is an important wireless data delivery network, how can it be part of a converged ecosystem? And this comes to my fourth point. Engineers need to get to work. Despite these commonalities of purpose, there are multiple incompatible regional digital terrestrial television systems, and this fragmentation hinders broadcasters' ability to address the changing environment as a unified group. Meanwhile, global data delivery standards such as Wi-Fi, 3G, LTE, and 5G have proven to be very successful. So in my mind, there are two aspects of convergence when it comes to thinking about broadcast. There is convergence among the regional DTT standards like ATSC, DVB, ISDB, and others. And there is convergence between these regional DTT systems with global wireless data networks such as LTE, 5G, LTE-based 5G broadcast, Wi-Fi, satellite networks, and more. ATSC believes that global DTT convergence among the regional DTT systems is a valuable and attainable goal. It can inspire broadcasters worldwide to develop a common voice on international issues affecting the broadcast community. Convergence can be a catalyst and perhaps even necessary for traditional broadcasting to become among the technologies utilized in a heterogeneous data network ecosystem. The possibility of full convergence across existing DTT systems may not be feasible, as installed infrastructure and consumer devices cannot easily be replaced wholesale. However, there exists the chance to converge and cooperate where various standards intersect or overlap. Furthermore, IP-based broadcasting is becoming the norm in the next generation broadcasting systems. The Internet Protocol Foundation of Advanced ISDBT and ATSC 3.0 and the recent addition of DVB and IP all offer IP-based data delivery services. This opens an opportunity to work toward a unified global broadcast approach that shares common ground among these regional systems. But while certain areas of DTT standards may necessarily differ, DTT technologies could present a common face to other data delivery systems in a heterogeneous system. Consider one or more abstraction layers that could be developed that lie between the global data delivery networks, such as 5G, and the major DTT delivery networks. In this way, developers of the global data delivery network need only concern themselves with the abstraction layer technologies, which would then interface with the various regional DTT networks. ATSC 3.0 is designed to interoperate with other IP data delivery networks as a fundamental feature of the system. In the physical layer, the ATSC 3.0 bootstrap signal enables robust reception and evolvability, and also signals fundamental characteristics of the broadcast, so that receivers do not need to be pre-coded with this information. With the proper registry for the bootstrap signaling, it is possible for non-ATSC systems to coexist in the same RF channel with ATSC systems. This can be seen almost like an app store, where the broader community can develop and deploy technology. In the transport layer, as I mentioned, IP-based transport creates a natural point of convergence with other IP data networks. IP-based broadcasting is becoming the norm in the next generation broadcasting systems, forming the foundation of advanced ISDBT, DVB and IP, ATSC 3.0, DTMBA, and FEMBMS. In the applications layer, common video, audio, captions, and interactive systems can be employed. HEVC, SHVC, VVC, Dolby AC4, MPEG-H audio, and IMSC1 captions, to name just a few. And W3C-based interactivity and common encryption-based signals leverage the developmental efforts of the web. Many of these technologies are common among multiple DTT standards as well as non-DTT data network technologies, and the platforms can be developed to incorporate other codecs and security systems. For example, ATSC is currently developing specifications for CMAF and VVC, and is constantly adding new APIs to the interactive system. Next slide, please. But perhaps one of the most important abstraction layers that we're working on developing is what we call a broadcast core network. A new broadcast core network currently underdeveloped is envisioned to be agnostic to radio access technologies. It would be an abstraction layer that allows broadcast networks to talk to global networks without the global network needing to worry about whether it's talking to a DVB network, an ATSC3 network, or anything else. This broadcast core network technology allows broadcasters to group transmission towers into integrated networks for simultaneous orchestrated delivery of services across many transmission towers operated by one or a multitude of broadcast station owners. Acting as a primary interface, the broadcast core network connects enterprise customers to available spectrum inventory and allows multiple broadcasters to expose their available spectrum capacity for use to these enterprise customers. The broadcast core network also operates as an interface to other core networks, such as the 5G core or EPC. Next slide, please. As you can see, in the United States, we operate a number of broadcast facilities. In the previous slide, you saw one broadcast facility lit up. In this slide, you see all 210 markets in the United States lit up, but we still don't have a network. Next slide, please. The broadcast core network allows us to create this interconnected web of broadcast towers, which can operate not just in the United States, we just use this as an example, but anywhere in the world. So although full convergence across regional DTT systems is perhaps a long way away, new technologies such as the broadcast core network can create this abstraction layer between the multiple DTT systems and global radio access networks, making convergence a more feasible outcome. The broadcast core network abstraction layer enables many different use cases. In one scenario, an enterprise customer, such as a streaming service provider, wishes to broadcast certain highly popular content to edge cache devices in advance of peak viewing times. The customer schedules data delivery capacity through the broadcast core network. They upload the data to the broadcast core network, and the broadcasters that are participating in the BCN access the data from the core network, distribute it over the transmission towers, and send reports back to the customer via the core network to confirm data delivery. In another scenario where one-to-many traffic is congesting a unicast network, the broadcast core network could interface with a unicast core network to orchestrate broadcast traffic offload to any DTT system capable of delivering the data. In this case, the unicast core, such as a 5G core, has an interface with the broadcast core network, which includes business agreements between the broadcast network operator and the unicast network operator. During peak usage of common content, such as live sports video, the unicast core can connect to the broadcast core to divert this common content to the broadcast network. Well, all this sounds pretty good on paper, but it requires interfaces between the networks and devices that can receive both broadcast and unicast content, or solutions that address different types of devices with different transmissions. This is where TSDSI, ATSC, and similar organizations come in. Engineering solutions are needed to realize these efficiencies and opportunities. The ATSC 3.0, the ATSC Technology Group 3, number 11 ad hoc group on ATSC 3.0 5G harmonization was formed to consider potential architectures for how mobile network operators and 3GPP can utilize ATSC 3.0 for transmission of services such as highly popular video programming and data as part of the 3GPP converged ecosystem. Several scenarios were documented by TG311, including multi-network operator originated broadcast services like linear video or non-real-time data could be transferred to a broadcast network operator for distribution to broadcast receivers such as TVs. The 5G core interfaces with the broadcast core network to transfer content from the 5G network to the broadcast network. Another scenario is you have broadcast network originated broadcast services, which are delivered by the broadcast network using LTE-based 5G broadcast to future mobile devices that accommodate LTE 5G broadcast delivered on television spectrum allocations. The broadcast network operator can simultaneously broadcast the same or different services via ATSC 3.0 or LTE-based 5G broadcast. The main advantage of this solution is that it enables a content provider to deliver the same service or different services to different types of receivers using the same application and service layer functionality. And a third scenario, if we imagine future dual ATSC3 5G-enabled receivers, they could support functions such as traffic steering, switching, or splitting across the networks. This allows receivers to receive large data downlink from the broadcast network operation and unicast and control plane services from the cellular network. A new ATSC 3.0 internetworking function, which we're calling A3IWF, is proposed to handle the interworking between the 3GPP core network and the broadcast core network. The ATSC3 transmitter, together with the A3IWF, connects to the 5G core in the same manner as a next-generation radio access node is connected to the 5G core, i.e., to the application management function over the N2 interface for control plane data, and to the multi-class broadcast function over the N3MB interface for user plane data. And another possibility is also being explored. LTE-based 5G broadcast is a system designed to deliver one-to-many broadcast content to mobile phones. This system is not intended to reach television sets, but is specifically intended for the phones. The two transmission systems, 3.0 and LTE-based 5G broadcast, could share the same spectrum allocation band by time division multiplexing or frequency division multiplexing of the two waveforms. In this design, a given receiver, ATSC 3.0 or LTE-based 5G broadcast, will only receive its corresponding waveform, TVs rendering the 3.0 content and cell phones rendering the LTE-based 5G content. The basic designs of both LTE and LTE-based 5G broadcast and ATSC 3.0 have some degree of frame structure flexibility in order to enable the sharing of these radio resources. However, there are two features of this system that are not compatible. ATSC 3.0 has a frame minimum length of 50 milliseconds. Meantime, LTE-based 5G broadcast has a cell acquisition subframe periodicity of 40 milliseconds. Therefore, it is not possible right now to transmit a full ATSC 3.0 frame without conflicting with the requirement to also transmit a cell acquisition subframe every 40 milliseconds, as required by LTE-based 5G broadcast. ATSC 3.0 is commercially deployed in 3 countries, as I mentioned before, whereas LTE-based 5G broadcast is currently in experimental phases with no commercial deployments right now. With millions of ATSC 3.0 receivers in the field, any accommodation to bridge the gap between the two systems should be backward compatible with fielded ATSC 3.0 receivers. These existing receivers are not required to present the LTE-based 5G broadcast services, but it is necessary that they successfully ignore those frames in the bit stream and continue presenting ATSC 3.0 services. In one potential solution, the LTE-based 5G broadcast system is amended in such that every other cell acquisition subframe is dropped. This allows the full ATSC 3.0 frame to coexist with the LTE-based 5G requirement. This scheme, however, is not fully required with today's LTE-based 5G broadcast specifications. However, if the percentage and frequency of the cell acquisition subframe dropping is low enough and the specifications can be amended, the performance of the LTE-based 5G broadcast receiver may only be slightly affected. As I mentioned, LTE-based 5G broadcast is not being suggested for integration into fixed televisions. A converter box could potentially receive such a service so that it could be rendered on a TV, but broadcasters wishing to reach both television sets and mobile devices would need to use both systems if we were to employ this kind of converged scenario. However, ATSC 3.0 was designed as a mobile transition technology by itself. It performs better than others against moving receivers and even improves relative to other systems as speed increases from walking speed to vehicular speeds. As a transmission system, ATSC 3.0 alone could address both fixed televisions and mobile devices if the devices could receive the signals. ATSC 3.0 is already integrated into millions of television sets, but there are no commercial cell phones in the world today that can receive broadcast services from a television spectrum allocation, not 3.0 nor LTE-based 5G broadcast. So any opportunity for convergence of a broadcast network with a unicast network that is intended to address cell phones requires new phones for everyone. That doesn't matter whether you're going to use 3.0 or 5G broadcast or anything else. Everybody will need a new phone if you want to address phones using a television spectrum allocation. So what is the design of this phone? SDOs such as TSDSI, ATSC, ETSI, 3GPP, and others can develop and improve technologies, but technology is only part of the puzzle. Indeed, almost any technical challenge can be solved given enough time, talent, and resources, and engineers love challenges, so we will do it. But market forces have a major influence on what ultimately gets implemented and becomes successful services. What works for all the stakeholders in the ecosystem? What options truly generate demand from the people? And what solutions best serve the people? Next slide, please. Convergence across networks is already happening. It is up to us as an industry to shape our own future. India is actively exploring mobile-friendly broadcast technologies with 1.2 billion cell phones in use and the prevailing consumer habit of watching linear TV on the phone more often than on a TV. TSDSI has adopted or transposed ATSC 3.0 into a TSDSI standard, and the system is being considered as an Indian national standard. This would create the option for India to deploy, offering Indian stakeholders the opportunity to consider these factors, study the pros and cons, and ultimately decide what is the best system for the Indian economy and the Indian people when it comes to converged services, to televisions, cell phones, and multiple and massive machine-to-machine delivery. So with this, I'd like to thank everyone for their time, and I see that we might have a couple of minutes for questions if there are any. Thank you so much. I turn it back to you, Guna.
Thank you, Madeline. That was very insightful. I definitely enjoyed your presentation quite a bit, particularly your points about data offloading, the fragmentation-related challenges, and particularly interesting is where you see the architecture evolving as a layer between global DTT standards and 5G in particular. So, I mean, there's a lot of information. I'm not probably giving you everything I learned from this, but very, very insightful. And thank you very much. But I thought that we are ahead of time, but looks like we're again running out of time. So we probably take questions towards the end. We'll probably, see whether we can finish the panel discussion and come back to questions, if that's okay with you.
Sounds good.
Thanks, Madeline. Appreciate your time. So I'm now going to get into the next session, which is a panel discussion. So we're going to get into some spirited discussion here. So for that to happen, I want to just quickly set the context here, right? So when we talk about convergence, I'm particularly referring to the mobile and satellite industry coming together. I'm calling it the great handshake here, right? So if you look at it, but they have been collaborating from on an applications perspective for a long time, right? So I'm particularly referring to GPS and applications such as mapping, weather, and so on, right? And of course, then we started using satellite as a backhaul option. So that has been some kind of a collaboration going on, right? So the backhaul option is especially critical in places where fiber microwave backhaul is really not an option because of the terrain, cost, and things like that. But now the new thing is like now D2D, right? Direct to device. And we already see cellular networks working in tandem with satellite networks to provide emergency services, messaging, etc. So the promise of future looks even better with integrated phones and all that, right? But this sounds really great on paper, right? Let's go to the next slide, right? So, I mean, I kind of put this, hopefully it's my, faint attempt at humor here. Kind of shows, I don't know how many of you are familiar with Star Trek, but, you got this, teleportation sort of concept, right? Long time back, which is, I don't think it's ever going to happen, but if you see the guy in the spaceship over there, he's got two phones. He's got a satellite phone and a regular phone, and he's trying to teleport his people into Bangalore and urban and rural, right? So the reason I'm kind of showing it is because jokes apart, there are several challenges when it comes to making this relationship work, right? You got to go from dating to happily married, for example, right? So the problem in India is really more than 40% of a rural population is still unconnected, right? That's a lot of people, right? There are a lot of poor people living in faraway, unfriendly terrains who need connectivity, right? So we need to give them connectivity so they can benefit from some of the services that the connected people benefit from, right? I'm referring to things like e-banking, smart agriculture, and the government is also offering a lot of benefits, but they have to reach those people, right? But it's not so simple, right? I mean, how complex is this, right? So that's why we kind of put together a panel of people who are from different industries and who've been sort of involved in standardization activities and things like that, right? So we kind of broken the subject into like some kind of 4 categories, and we'll have each person give their perspective on each of those categories. Like, one is standardization, which is clearly becoming extremely important. 3GPP is taking up this in a big way. Release 17, release 18 is coming up. I mean, there's a lot of work going on there. And technology, right? Plenty of challenges there. We have Vinosh from Qualcomm who's going to talk about that. And from a deployment perspective, right? We have Satish from Nokia who's going to talk some of that stuff. And of course, to give a very holistic perspective on the whole thing with spectrum, cost, regulations, use cases, probably a little bit of services. We have an India from Tejas who's going to talk about that, right? So having said that, let's get right into the introduction of our panelists here. And I'd like to first introduce Abhijit. Abhijit Abhimanyu is a lead research engineer in Center of Excellence and Wireless Technology, CIVIT, India, with 9+ years of experience in wireless standardization. Is quite active with in 3GPP standardization work. The next slide, please. And India is a VP at Tejas with approximately 26 years of experience. He's an expert on software-defined radio, leading the baseband and RF system design for 5G products. In his earlier role as CTO of Sankhya Labs, he led the design and development of the baseband and RF subsystems for Sankhya's products and wireless communication. Glad to have you join our panel in India. Looking forward to hearing from you. Let's go to the next slide. Satish Kanigovi is part of the Nokia strategy and technology division and heads the standardization and industry engagements in APAC, focusing on India, Japan, and Korea regions. Welcome, Satish. And next, I have the pleasure of introducing Vinosh. Dr. Vinosh joined Qualcomm in 2011 and has served over the years in roles spanning engineering and standardization. He currently leads Qualcomm standardization engagements in India. So anyone who's working, who's been with TSDSI would probably very familiar with Vinosh. Thank you, Vinosh, for joining our panel. So let me let's get right into it. I want to first invite Abhijit. Let's invite Abhijit from CIVIT to give his perspective on ubiquitous connectivity from a standardization perspective. So, Abhijit, welcome again to the panel, and let's keep each of your opening remarks to probably around 5 minutes, 5 to 6 minutes, so that we can hear your perspective first, and then we can get to one round of questions, and then we can get questions from the audience. We're expecting a lot of questions from the audience, so we'll try to address all of them in the next 30 minutes. Go ahead, Abhijit.
Okay, thank you, Mr. Guna. I hope I'm audible.
Yes, you are.
Yeah, thank you very much, and thank you for the opportunity. So I'll be discussing as an opening remark on the standardization activity that are happening. I will start with the necessity that 3GPP. So mainly I'll be talking about the 3GPP standards, which is NTN. So I'll start with the necessity of NTN that has been discussed in 3GPP, and then I'll just keep a overview on release 17, 18, and 19 activity. And I'll just touch a little bit on expectation on 6G. I think the next panelist will discuss more about that, but I'll just introduce that part. Yeah, so to go with the necessity, as you know, the wireless demand is growing day by day. But again, as at the beginning of the session, Mr. Mahesh explained about the coverage hole. And the coverage hole, sometimes it is not viable to cover with the cellular network only or terrestrial network only. So in that case, SATCOM or satellite communication will come for a rescue. So it will complicate that. It will complement the terrestrial network, especially for the mission critical applications for the ubiquitous connectivity. So that is how satellite communication is in view as a complement to the terrestrial network. But that's not the only part. As you know, the satellite communication is growing rapidly, but the proliferation is a bit limited because of the cost of the terminals and the equipment. So it has been viewed with this kind of integration with the terrestrial network, the satellite communication, or the in general the cost of a terminals and the equipments of satellite communication will go down. So that is the another motivation or the main idea behind the integration of satellite communication and terrestrial network in 3GPP, which is popularly called as a NTN. So can you go to the next slide, please, Akash? So these are just use cases. Again, the use cases that are considered at the start of the work in 3GPP, mainly on IoT, M2M, machine-to-machine communication, then satellite mobile backhaul, rural and enterprise broadband, direct to cell phone, and voice and data services. So these are the use cases are considered around which the 3GPP activity is revolving. Can you go to the next slide, please? Here, I'll just give the overall standard progress from release 15. As you know, release 15 was the first standard for the 5G, but it was not having an inherent support for the NTN. Rather, the study of NTN was started in release 15, mainly on the channel model and the use case point of view, which is documented in 38811. And then subsequently, the second study was taken up in release 16, which was mainly on focusing on the impacts that NTN integration will have on the 5G networks, which is documented in TR 38821, which now these two TRs was a baseline for the normative phase, which is carried out in release 17. So this is release 17 is the first standard for the 3G for the NTN in 3GPP. It supports NR NTN over 5G core and IoT NTN over EPC, which is LTE. So these two technologies were standardized, mainly for the for NR and IoT kind of applications. Going ahead, in release 18, some advanced. The last slide. So release 18, some enhancement, or release 17 on coverage, security, mobility, and IoT considered. Release 19 was another second phase of evolution on NTN that has been considered, which will start in the next year onwards, March onward, especially covering the regenerative payload, new architecture, new use cases, and enhancements. And release 20 and 21 are considered as an 6G release, which will have inherent support for NTN and TN simultaneously. So that is what is the 3GPP and the future planning for the standardization activity, at least from the 3GPP point of view. Can you go to the next slide? Just to put some perspective on the spectrum that is being considered in 3GPP, right now in release 17, FR1 is something standardized, especially band 256, 255, 253 and 254 are newly been introduced in FR1. There is a study in release 18 going on for the FR2 band, which is about 10 gigahertz band, especially in KA band from 17.3 gigahertz to 30 gigahertz. This study is still undergoing, which will be finalized somewhere in the March next year. So can you go to the next slide? To end my presentation, we just give a perspective on the expectations from the 6G. So right now, if you see before 5G, it was two different technologies, satellite communication and 5G. In satellite communication and cellular communication, in 5G, we are trying to have some integration which sits together. But in 6G, it is been planned that it can be completely unified so that it can flawlessly, it supports both NTN and TN network. So with that, I think I'll stop my presentation. Over to you, Guna. Thank you.
Thanks, Abhijit. That was a good insight and good overview on what's going on the 3GPP standards with respect to the NTN integration there, ubiquitous connectivity. So that kind of sets a stage nicely for Vinosh, our next speaker from Qualcomm. Vinosh, I would request you to give us your perspective with technology as a background, as a context, and you also can also expand into 6G, for example. Please go ahead.
Sure. Thanks, Guna. Just checking if I'm audible.
Yes, you are.
Yeah, thank you. Happy to be part of this panel and then trying to give my perspective on this particular topic, right? So getting directly to the point, I think we need to address the elephant in the room. And that particular element is, you want all this convergence, unification, all those things, but the end delivery device is a mobile device, right? So we are talking about technology which need to get in there. And that's the reason, 3GPP is getting prominence, because that's where the mobile technology gets standardized, right? And over the year, what we have seen is 3GPP moved away from offering voice service to then data services with 3G in the later part, and then with LTE and other related things. And then it started diverging into a lot of other industry verticals, right? So for example, IoT along with narrowband IoT was like one good use case. Cellular V2X, where adoption is happening now, that's another use case. And the same cellular technology then tried to find into different verticals, which had its own complications, right? So we were able to see that particular messaging come through in Madeline's session as well, where she was basically articulating on how broadcast needs convergence with the broadband world, and what are the challenges, opportunities, and ways to go forward with it, right? So I'll focus on two aspects, mainly aligning with the theme which Guna proposed, that how do you make this valuable for India, make it applicable to scenarios which are more relevant to us, and more importantly, how to ensure that it is in a timeline which is also making sense, right? You don't want this 40% get connectivity 40 years later. We should probably try to get it in the next year, 2, or maybe like 4 to 6 years, right? So that's sort of the aspiration. So 3GPP, of course, is in the path, but still not fully there, right? Again, no surprises in here, because businesses drive the innovation, and then a fallout to that is the societal cost. I'm being honest in here, right? So focusing on this particular one, my approach to that is, if you want to talk about convergence, then you should talk about something which is more like a general purpose technology. So if 3GPP is going to develop the next standard for 6G, how can we ensure that it produces a general purpose technology which will adhere to several different requirements, including automotive, satellite applications, broadcast applications, probably even more, right? So the same 3GPP technology which is developed for cellular application need to be leveraged by vertical industries. Point number one. Point number two is this is critical because if the mobile device is the end device, then we need to minimize the impact to those receivers and ensure that they are hardware compatible with the cellular model, right? There are two implications, right? One is trying to get the same stuff into a mobile. Second thing is expanding the same stuff into other devices, right? So for example, the same mobile device then becomes your dashboard of a car. It becomes the same mobile tablet which you are given, for education purpose and other related things. So the moment you try to address it into a handset, your application just explodes, right? So that's sort of the opportunity which we try to latch on. Next slide, please. Maybe one more enter. I think there's a picture missing. Yeah, okay, right. So this is sort of, where we are today, what is aspired to become later, right? So Abhijit nicely characterized in a tabular form the different releases and what they are expected to do. I'm just complementing it with a figure saying that, 3GPP is trying to address the satellite industry or whatever in terms of, how high the altitude you are currently from the Earth, right? And if you are looked into recent announcements from Qualcomm, we have a system in place and a corresponding chipset which supports it to enable NB-IoT satellite applications, right? So along with Hughes and Ericsson, we were able to do a trial, and then the platform is now available, which can be leveraged. This is just going to grow, right? Meaning, NB-IoT, it's more of tracking applications. The limitation comes because the channel bandwidths are also low and the capacity is low. So using it for voice services will have its own limitations. But as the satellite capacity increases and then advanced MIMO and other options comes up, we will be able to see more applications like what Abhijit mentioned in the previous slide. The same way, technologies developed in there for cellular and broadcast, you are able to leverage the same 3GPP technology to do both, right? So that's sort of, the advantage on why and how it gets into your mobile phone. More importantly, I want to focus on the thing in the right-hand side, right? So if you're able to zoom in somewhere in there, there is a clear thing called interoperability and interworking. That a 6G technology to be developed needs to interwork with other systems. That's sort of, the design principle given by ITU for a 6G standard to be developed, right? And if you look into the framework document, which was approved by Study Group 5 last week, it's spread in multiple places that, it needs to be inclusive, interwork, and other related things, right? So that it's not 40 years, that part is clear. It's going to be like in the next 4 to 5 years, right? Assuming that, 2007, 27, 28, you will have the first generation of systems coming up. It will interwork, right? I'm positive about it, but there is still a lot of steam which need to be pumped in to make the engine running, right? And let's see how the questions are coming up, and then I'll be happy to answer them as well. Back to you, Guna.
Thank you, Vinosh. That was crisp, clear, and up to the point. Appreciate you giving the perspective on it, and particularly the point about silicon using the same silicon. Essentially, you are alluding to volume, which is essentially helped bring down the costs down in the long run, right? When you have bigger volume. So, and all those perspectives are great, very insightful. Thank you. I think we learned a lot. So I'm pretty sure there's going to be a lot of questions coming up. So we'll bombard you later. And let me go to the next panelist. At this point, I'd like to invite Satish from Nokia to give his perspective from deployment challenges as a context from an India perspective. So, but in the overall context of ubiquitous connectivity. So, Satish, please take it away.
Okay. Namaste, and thanks a lot for this opportunity. So there is a popular saying that you should speak only when it adds any more information or value to silence. And speaking after so many esteemed experts, I will try to take some exceptions because much of what had to be covered has been covered. But still, let me try to make justice of the couple of minutes that I have to lay down the context of the discussion that we are going to have in a couple of minutes from now. So the theme of this session is about ubiquitous connectivity. So I thought it would be good to start with the way it has been defined and to point out certain aspects that are very salient or important. So when IMT 2030 talked about ubiquitous connectivity, the key aspect was to enhance connectivity with the aim to bridge the digital divide. And then when we talk about digital divide, it could be related to coverage, which is covered in the next point, which talks about address presently uncovered or this scarcely covered areas, but also in terms of the services that you would want from that connectivity after it reaches that particular location. So the aspect of applications and also the location at which those applications need to be supported has to be very carefully considered. And then, so in the end, the definition also talks about typical use cases. So these use cases would again depend from geography to geography, location to location. What are the typical use cases that need to be supported? So with that background, maybe we'll go on to the next slide, Kash. Yeah. So this is an excerpt from our own Bharat 6G vision document, where it talks about the range of applications that need to be supported when we are talking about ubiquitous connectivity. So it could start with smart classes, where you need to deliver video to a classroom, say in a village or in a city, to say commercial banking, which has completely different requirements as compared to what you need for delivering classes to to a remote classroom. Okay, and then it also talks about robotic healthcare center, and then it also talks about digital schools, remote ATM, smart electric devices. So if you look at the range of aspects that need to be considered in ubiquitous connectivity, it is very obvious that we have to look at it from a very use case centric perspective rather than a technology solution perspective. So I think this is what Satish Jamdagni also had indicated earlier in the call, that when we are designing 6G, we have to really take into account the wide range of use cases that we need to support. Then I think Mahesh also, in his opening note, also talked about the different locations, whether it is lift inside a building or it is somewhere in the jungle. Where is it that we want, and what is the service that we need to provide. So with that, we can go on to the next slide, which then talks about the role of mobile connectivity. So this is an excerpt from the Nokia Mbit report. It is a very fine report, and I think I would recommend all of you to get a copy of it. This one, so we publish it typically February of every year. So this is a little dated one, but it gives some good perspective. It it actually indicates how mobile connectivity has been playing a stellar job in terms of delivering broadband to the masses, particularly in a country like India, as compared to other geographies, whether they are in the west or further towards the east. We are a cellular first nation, and then the mobile connectivity technology, or what we call a cellular, has done a great job in terms of ensuring that we have people in the remotest locations get access to connectivity. For many of us, cellular broadband is the first broadband that we have been given access to. So one key point I wanted to pick on this particular set, although there are many interesting aspects here, is that if you look at expected subscribers by around 2024, we expect 5G itself to cover around 150 million subscribers, and the combined 4G plus 5G, which will again, of course, tilt towards 5G as more and more deployments happen, as the technology rolls over, depending on the data needs of the subscribers. We expect around a billion, 990 million, as it is shown on the screen, to be covered by the combined 4G plus 5G. So which takes us to the next slide, which actually talks about, in terms of providing ubiquitous connectivity, my speakers previously have already talked about different technologies that are appropriate for delivering connectivity, whether it is satellite, whether it is broadcast. So different applications require different things. And if we are talking about providing mobile connectivity to all, what are the different considerations? As we saw, there are a variety of applications that need to be supported. Different applications have got different KPIs. So there are different needs of latency of an application where you have to do AR, VR kind of interaction, versus a different throughput requirement when you have to deliver a video class to 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 a remote school. And also in terms of affordability, the kind of affordability that would be there for a person in the city would be very different from the affordability of a person availing availing the same service, in fact, in a tier 2 town, or whether it is a village. So all these things have to be kept into picture. And I think Abhijit made a very good comment on the aspect of cost of different technologies. So in terms of cost of delivery of connectivity, mobile has done again a great job, but there are obviously areas where mobile is not able to reach for whatever reason, and we will talk about the challenges why that happens. But then satellite has, obviously, the cost at which the connectivity comes is different. So therefore, we have to look at a holistic approach in terms of what is the requirement of the application and what is the affordability of the consumer of the application, which is a very key thing. So that brings us to the next bullet, which actually expands on the first bullet, which talks about application needs, is that we have to talk about ubiquitous, or even, if I may say, minimum quality that you need across the coverage area. So there are two growths just to enhance the focus on growth. But as we grow the serviceable areas, we have to offer a certain guaranteed data throughput. I mean, and I have used data throughput as a generic term, but it is a guaranteed KPI, whether it is in terms of latency, throughput, or even if you include affordability, or even energy consumption, because energy availability at different places of where you need service might be different. Spectrum plays an important role, which is what is the subject of the third bullet. So what role of spectrum? I mean, it is very difficult to overstate the criticality of spectrum. Lot of coverage and service continuity can be achieved by access to good spectrum. And when I say good spectrum, spectrum that reaches far, which is low band to mid band spectrum. So now, with all these considerations, let us also probably, before we get on to the panel, I mean, talk about what are the different targets and challenges. So what are the targets when we talk about ubiquitous connectivity? Is it a ship in the ocean, or a hut in the jungle, or is it a shop in the village, or it is high rise in a city? So depending on the location, the kind of applications that you need, the kind of affordability, and the kind of technology that can be used to deliver would be completely different. And then we have had a lot of these technologies, which are, of course, getting improved over a period of time, whether it is broadcast, satellite, or cellular. But then there are issues beyond technologies, which is where, Guna was talking about deployment challenges, which have to be considered. Availability of power, availability of the nature of power, whether you have the electric grid or it is fossil fuel based. If it is fossil fuel based, how do you secure? I mean, pilferage is a big issue in some locations. So, and then you have got backhaul, whether it is at all available, or whether it is available to the tune of supporting the required applications. Vinosh talked about importance of devices. It can again not be overstated at all. The kind of devices, the requirement of the devices to support different technologies is going to play a key role, which is where standardization bodies like, for example, the GPP, where there is a big focus on how the devices interoperate with the network, play a key role. Spectrum, as I said, availability of good spectrum, and also spectrum for the coming generations should be such that it is easier for us to upgrade technologies. Say, for example, there have been studies where we saw that, we could potentially use the same grid when we are talking about centimeter wave till 6 gigahertz. And therefore, one of the stress, and we are very fortunate that, India has also supported that, is we are looking at 7 to 15 gigahertz kind of range, even for 6G, so that, it allows easier deployment of the next generation technology, which will allow us to reuse the existing base station grid. So that itself is a big deployment challenge if you have to, look at different set of sites for the deployments. Then, of course, regulation plays a key role. And as we know, in India, we have TRI, which actually indicates what is the minimum amount of KPIs, what are the minimum set of KPIs in terms of QoS, coverage, etc., that are to be supported. So that also plays a key role in terms of, technological solutions to be provided. So in all, just to summarize, what I would want to say is that providing ubiquitous connectivity requires a collective effort, and it is not going to be okay. So let me put it in a positive way. So the onus is on different stakeholders of the technology ecosystem to work together to ensure that we can deliver what we have been promising to our people as technologists over so many years. Thanks a lot, Guna, and I hand it over back to you.
Thank you, Satish. I think that was quite good, and I definitely appreciate you touching a little bit of services also from an India perspective, and some of the challenges related to equipment provider as yourself. Again, for the rural unconnected in India. So good opening remarks. Thank you. So let's move to the next panelist here from Tejas, my good friend Anindya. So I'll like to invite Anindya to give us like a more of a holistic view on costs, architecture, spectrum regulations, even energy, sustainability options. Sort of we heard a lot of things from a lot of different people. I mean, we'd like to hear from you, sort of like putting everything together, sort of. So please take it ahead.
Thank you, Guna, and thanks for the opportunity. I think one of the advantages of speaking, much later is that most of the people have already covered the points, but I'll still try to give my perspective. So the problem of the connecting the unconnected is kind of not new. It is very well aligned with the United Nations vision, the sustainability goals, and I've just tried to list a few bullets. Of course, the United Nations has already mentioned that the wired and wireline technologies are playing a very significant role in trying to connecting the unconnected or even the underconnected. I've just tried to highlight a few sentences, but I'm not going to go through all of that in the interest of time. But this high-level panel on digital cooperation kind of focused on some three very important recommendations, which I've listed here: 1A, 1B, and 5B. And one of the things that is being talked about at the backdrop of this G20 summit is about the digital network, the digital public goods, and digital services. So one of the important things, as you see, the first recommendation made, 1A, talks about affordable access to digital networks and also talks about digitally enabled financial and health services being made available. The other thing which recommends is to have a multi-stakeholder alliance to create a platform for sharing digital public goods. So this concept of digital public goods has become very, very prevalent, and India kind of is seen as someone who leads in that. And the other important thing is, seeking cooperation and a regulation that is agile, inclusive, and fit for purpose. So all of these things are very, very important when we are talking of connecting the unconnected or the interconnected. And we'll go to that a little bit in detail as we go to the next slide. So can we go to the next slide? So I have tried to list down certain points. I think this is basically a combination of needs, challenges, and maybe some enablers. So what does I'm just going to talk about it as CTU, the connecting the unconnected problem. One of the most important needs, and I think previous speakers have already spoken, is you need to have very cost optimized networks which are really open and which fit the use cases of connecting the unconnected. And if you look at that, you need to have, what does it mean on the ground? On the ground, it means that you need to have technologies where the backhaul connectivity can really meet the use cases. They are stable. And again, cost is an important factor. Can I get long range with low power? Energy sustainability is also an important aspect here. And can I use, for example, we talk of beamforming and all that. Can I use some very smart ways of beamforming so that I really expend low power, but I'm able to connect the unconnected? Then, a lot of technologies are also there to provide local coverage. Can I use some kind of mesh or interconnecting technologies, D2D, to bridge those gaps? Because if you look at all these rural communities which are really unconnected, you will find that they are actually in clusters. It's not that they are spread over a large area, but then they have clusters. So importance on having local coverage as well as backhaul link to these clusters is very, very important. So we need to think of technologies, cost-effective technologies, open architectures in that way. I think the other important point which I come to is the spectrum, and I think this is a kind of a controversial topic. But then, when it comes to connecting the unconnected, there have been a lot of attempts made. But then the most popular has been usage of the Wi-Fi spectrum because it is unlicensed. So, as more and more users get onto this network, it will need some kind of rethinking on part of the regulators at some point in time to come up with more cost-efficient models of how to enable spectrum resources for very low-cost deployments. This is something which is a very contentious topics, but then this is something, if we are really serious about the CTU problem, this is something which really, really needs to be looked at. The other important things which I have tried to mention here is how do you manage the content? Specifically, if you look at very local communities, rural communities, you might like to have very low cost edge solutions which can manage the local content. And then, if you're looking at the unconnected and people who are digitally disadvantaged, you might also like to have very simple ways of ensuring authentication, security, having human computer interfaces technologies which are very, very affordable, but easy to use. The other important point which I have listed here is about power and energy. So this is very important. I mean, no matter how much of energy we have, if you're able to operate networks which are off grid, nothing like it, and where power is intermittent. So this is where a lot of people talk about networks which have very, very low overhead. I mean, I'm sure people are thinking about it even in context of 6G, where people are thinking of coreless networks or something which is a very light stack, not a very heavy stack, but a very light stack. And coming to my last point, let's say we build a network, how do you make it sustainable? Have you ever thought about that? So we need to have also business models around which can leverage, the rural setting, the rural communities, the communities which are not connected, so that they get tied to a larger global ecosystem. And I think if I really look at it from a technology point of view, I feel we already have technologies which can solve this problem. But I look at it more like holistically in terms of a multidisciplinary problem which has business models, which has energy, which has spectrum regulations, as well as technology tied to it. So that is how I have been looking at this concern of connecting the unconnected. And if I go to the next slide, there is one kind of architecture which has been proposed. This comes from the IEEE International Network Generation Roadmap, the INGR, and there is a report on connecting the unconnected. And this is a very high level, 20,000, 50,000 feet thought on the fact that maybe we should, to make, digital public good available to, a wide variety of people and connecting the unconnected, you probably should have a very thin slice, which is free. And so you should have a very thin slice which basically makes the digital public goods accessible to most of the public, especially who are unconnected. But when you are giving full access to the internet services, maybe then you can make it subscription based. So this is one of the thoughts which has been which are being toyed around, or which are being discussed, especially in some of the I would say study groups in IEEE. Especially the CTU, IEEE conducts workshops as well as contest challenges every year on connecting the unconnected, and this is something which has come out of that. So I think with that I would stop. I kind of feel that today, even with 5G, a lot of technologies already exist, but it requires more of a holistic, multidisciplinary approach to address this problem. Thank you.
Thank you, Anindya. That was very, very good, very insightful, and actually, since please stay on video, because I think since you just finished the presentation, let's just get to the next question fresh off the press, right? So, I mean, you mentioned a point, and you also said it's a bit controversial, right? But that's what I like to double click into a little bit more.
Sure.
I kind of like controversies a little bit here. So, but I mean, what you said was so apt, from providing the challenges related to providing services like a country in India, right? And your point about using unlicensed spectrum is well taken. But there is also when it comes to non-terrestrial networks, also there's a whole bunch of regulatory challenges comes into play, because you've got they've been operating in a separate spectrum altogether. We've got mobile companies operating in a separate spectrum. Now all of a sudden everything is merged. You're also putting base stations and satellites now. That's something that regenerative payloads and stuff like that, right? So, I mean, all of this sounds like a little bit too much, in the sense that, I mean, can you give your perspective from a regulation perspective? What are we really looking at? What are the real challenges? I mean, ITU comes into play. I mean, how big of a problem are we talking about here to make things really happen and help the people in India, for example?
I think if I just, zoom into this problem of connecting the unconnected, I think what is required is some kind of mechanism where uh, 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 a slice of the spectrum is kind of made affordable, or given to the public in terms of what is called as the digital public goods. And this is a term which is kind of oft repeated now, but you are just making a very small amount of spectrum available for the common good of the society, and it should not be very hard. I think earlier a lot of studies have been done, a lot of reports have been made. People have talked of light licensing. People have spoken about leasing the spectrum to unconnected communities. So a lot of those things, are there for to be explored by the regulators. I think we typically try to steer away from that. But as a country, now that we are getting serious of delivering digital public goods, I think this needs to be probably relooked at more closely and rethought.
Wonderful. Um, Wonderful. Thank you for that perspective. Um, I'm kind of getting into the same theme from a challenges perspective, right? I mean, uh, implementation challenges with respect to convergence. I want to bring Abhijit in here, and Abhijit, you gave a lot of information. You presented a lot of information about standardization in particular, right? And 3GPP has taken up this challenge when it comes to integrating NTN. But I mean, there's a lot of technology-related challenges, right? You got talking about long delays, Doppler delays, and so on, right? So, can you take a few minutes to explain how 3GPP is sort of tackling all of these challenges and making sure that everything plays well with each other when they actually gets deployed, for example. Thanks.
Yeah, thank you, Guna. Thank you, Guna, for question. So yes, I can give a little bit of insight on the way 3GPP, because I will be restricting myself only for the 3GPP because there are different forums which solve these issues. But again, I'm just aware about how 3GPP has brought in the solutions towards the problem that we see in the satellite integration. So as I mentioned in one of my slides, that release 15 and 16 was dedicated for the study, and during that study, the main purpose of the study was to understand, because initially it was completely new for a terrestrial technology people to understand the satellite communication. So it was bit of push and pull we experienced in 3GPP to have a common understanding across. And that's the reason it took like 2 years or more to bring everybody on the same floor from the technology impacts that one can have on terrestrial networks and vice versa. So if you see the study, especially the documents I mentioned in my presentation, it is a very extensive study with evaluations of different constellations that have been brought in by satellite community in 3GPP, and then we sought for a common understanding on the channel model, use cases, impacts on the NTN. So out of that, what came out of is the two main part, at least from the RAN point of view, is the delay, as you rightly mentioned, that Doppler and the delay. So if you see, and there are multiple, and it varies across different constellations. So what 3GPP decided to focus on is a geo set constellation, which is geosynchronous Earth orbit, and then LEO. LEO is a low Earth orbit. So these orbits were actually decided to finalize to study first, at least in study phase. And then it came out that the delay is a killer for the integration. And then then different solutions were being sought, how exactly we can go. I'll come to Doppler later, but let's talk about delay first. Uh, then there was two ways we can go. So let's redesign everything, considering the longer delay, or try to do a little bit fix so that the initial framework remains same, but we will do some delta on top of what we have already done in 5G. So we decided to go the later way. So it's like let's keep the 5G things intact, and let's do a delta additions to what we already have in the 5G. And that's the reason, if you see, the delay has been managed by with the help of with the terminal itself, which is something new that has been done especially for the NTN integration. So right now the GNSS support for uplink synchronization is something that is very much necessary to have an NTN deployment or NTN realization. So that is what something is. It came as an as a study outcome of NTN. Coming to the Doppler part, yeah, so for the geo constellation, though there will be a little bit of Doppler, as it is very constant relative to the Earth. It is not a big issue, but the issue is in the Leo constellation. And but again, at least for now, it has been decided that it will be done as a implementation based approach. So it will be a pre-compensation that is that has to be done at the device end. Standard, at least now, do not support any kind of standardized approach to compensate the delay. So around these two main issues, a lot of stitching across the specifications at different group took place, and that is where the support has been brought in release 17 onwards.
Thanks, Abhijit. Thanks, Abhijit. That was a good detailed reply. Appreciate it. And I just realized that we are running out of time again. So we're going to. So I'm going to bring Vinosh back with a quick question. Vinosh, I want to kind of double click on some of the things that you mentioned. You kind of touched upon costs, and you gave a wonderful perspective on how integrated silicon, increasing volumes and things like that is going to help the overall cost down, and how all of this is extremely important from an India perspective. So I'd like you to kind of dial down that a little bit from an ROI business model perspective, some of your views, and if you can keep it short, I think it'll be great. Sorry, thanks a lot.
Okay, you asked me a loaded question and asked me to respond it briefly. Very good.
Thanks.
Okay, I think the trick in here is the general purpose technology, right? Even if you look into the NTN use case, why did it come? Right, it was developed for the West, to be candid. Right, there were like people who could afford it, but due to them remotely living or being in obstrusive terrain, giving them regular connectivity is going to be difficult, right? So that's the reason all these business cases came up into 3GPP and got standardized, right? So obviously the expectation is the solution is going to be costly, which then means it is not going to be applicable for Indian scenarios. Then how do you make it applicable for us? The only way we can do that is by doing product innovation. Meaning, we need to have our startups and Indian industry focusing on customers to be serviced in here, and then leveraging the volumes that can potentially come in addressing those things. And probably we should think about new use cases as well, right? So if you look into some of these NTN use cases, the end device need not be hands like in a cellular phone, right? You can always have like a receiving station which is still 3GPP compatible, and then as Anindya or others were mentioning, you can use Wi-Fi or other technology to basically relay it to the end consumer, right? And if you look into the price point, you get Wi-Fi capable 4G 5G devices at sub 10,000 rates, right? So that's one sort of way you can actually solve this problem, right? So I think in India we call it a dabba, right? So the whole idea is, can we build this dabba which can actually then integrate or interwork with different technologies. Say, for example, it has like a very a good antenna which can receive satellite signals. It possibly has fiber connected to BharatNet or something, and then wherever network connectivity is available, it is able to connect to a cellular tower, and then either use cellular or Wi-Fi to the last mile. It's still a dabba, right? Meaning I haven't seen such a product still available there. But if policy instruments can be put in place to ensure that somebody manufactures that dabba in volumes, maybe we have our solution.
I like that. I like the dabba idea. In fact, I love the dabba idea. So I think hopefully you got entrepreneurs and equipment companies listening to this conversation and creating a dabba. Hopefully we can talk. It's going to be real dabba in production at some point, and which would solve and nicely put everything together from a hardware perspective in terms of what. In summary, really, we have to look at it from an India perspective, our use cases, the challenges, so that we can actually provide the services to the people at the cost point they look for, right? And that needs a fresh thinking. So definitely appreciate that. I mean, we have a lot of questions, and I just wanted to. I think we're going to run out of time a little bit, but I'm requesting that we're going to go a little bit longer. Hopefully, everyone is okay with it. Sorry about that. The topic being so interesting, it just we got about 13 questions, right? So I want to give throw a quick question to Satish, and then we can probably get on to the questions from the audience. So Satish, one thing I wanted to quickly pick your brain on is like from deployment perspective, it doesn't necessarily have to be Nokia, but in general, right? You got there is proprietary implementations already out there, and there is standardization stuff is also going on. I'm referring to NTN and things like that, right? But everything is going to change pretty soon at some point, right? So, how do you see that? From a migration perspective, how do you guys typically go about thinking about all of this stuff in general? A few minutes, please.
So, thanks a lot. I mean, firstly, you have a tough job. You tried to pick my brain, but then you gave a very tough question. So I don't know what to say. But so when we think about migration, as I said, we always start from the perspective of the services. I mean, what is the addressable market in terms of services, and then the location, and then we come to the most appropriate technological solutions. So from that perspective, some of the questions that we saw on the chat were also very insightful and actually provide pointers to the way this thing we think should be thought through. In terms of a common security architecture that we would require across different systems, right? So that would mean that it would be ideal to have a single architecture that would take care of security while having the ability to provide the desired coverage in the last mile, which is the wireless part, with the appropriate air interface technology. So that would be one way of seeing how we migrate different services which would require interworking or some kind of mobility across different RITs to be handled by a common system. That is one way of looking at it. And then the other way, when we are looking at deploying the systems, is the capability of the device. And like indicated, ultimately those technologies get deployed which have a viable device ecosystem. So depends on not only the technological aspects in terms of how complex the device becomes for it to be viable. It also depends on the kind of power requirements, the kind of cost that actually comes into being. These are the different aspects that we take into, that we think should be considered when we are talking about migration, and if I may, interworking across different systems.
Thanks, Satish. Appreciate it. So I'm just kind of in the interest of time, we're just going to cherry pick some of the questions and hopefully we can. There's no way we're going to get through all the 13 questions, guys. So sorry about that. Wish we had more time. So let's pick. I want to give. Hopefully, Madeline is still there. I want to give a chance for Madeline to speak on one of the questions from the audience. Let's see. At present, which DTT standard is in force in India? What is the timeline for ATC 3.0 adoption in India? It seems like a very specific question. I'm not sure. Madeline, do you?
Well, I can try.
Okay.
There are DVB T2 deployments in India. There is also the experimental deployment of ATSC 3.0 in India. And I think that there is a very strong desire for broadcasting direct to mobile. And I think that the solution for achieving that goal is still being discussed and considered. And certainly ATSC 3.0 is among the technologies that would potentially fulfill the wish for that. Unlike Brazil, Jamaica, Trinidad and Tobago, and others, there's no government mandate within India to make any change to the DTT system. There is, at this moment, opportunities for the ATSC 3.0 system to become an India national standard, should the government opt to do so. And perhaps we'll see what happens from there. But right now, I would say that India is very much in exploration mode, and they're way down the path in making those explorations. And we shall see where TEC proceedings and others go as far as whether or not a mandate is ultimately decided to be enacted or not, or if it becomes a voluntary transition. So I would say that those questions are very much in play right now. So I hope that's not really an answer to the question, because there isn't a definitive answer right now. I think that those who are interested in the subject would hopefully become involved with the stakeholders that are having the conversations. Thanks.
Thanks, Madeline. Appreciate your perspective. We will send the other questions your way, and hopefully you can answer them later too. So I want to take a quick next question. I'm not sure who wants to pick this up. From Udra, given that Bharat 6G is centric around Bharat 6G specific requirements, was EXA X 6G IoT document utilized D1.3 or D1.4 as foundation? Any takers for this?
Yeah, so I can probably very briefly add and also responded it over the chat that as part of the different discussions that actually built up to the formation of the Bharat 6G vision, we had invited experts from HexaX, we had invited experts from the SNSJU, and also we had NextGA folks coming in, and we had very good discussion, and their inputs have been considered. I mean, I cannot go to the extent to say that they are the foundation of what has come out, but certainly those aspects have been considered as we developed our own vision for Bharat 6G.
Great. Thanks, Satish. Okay, so in the interest of time, I think we should probably take the rest of the questions offline. Very sorry about that. We ran out of time, but I want to take this opportunity to thank our wonderful speakers and our wonderful panelists for their wonderful insights, and I think we learned a lot. Thank you very much from the bottom of my heart. So what I want to do next is let's go back to our deck, Akash. So we are reaching the end, and I'd like to invite Avinash Ji to give our closing remarks. And can we do that, Akash? Can we get back to the deck? Avinash Ji, are you there? You can start talking if you don't need slides.
Okay.
You can turn the video on.
Yeah. Okay. So thank you, and I think it was a very long day and very fruitful discussions. In fact, we are already running out of time. I will just try to quickly summarize and share a few pointers. In fact, the topic itself is very interesting, like advancing ubiquitous connectivity through convergence. And everyone has already talked about what is ubiquitous connectivity. And in the first session also, we talked about the 6G framework and other things. So uh, essentially, like just to summarize that, it means connecting the unconnected or bridging the digital divide, access to variety of services anytime, anywhere, any device. All those are related to ubiquitous connectivity. But then this session was also about convergence, and so a lot of things were discussed about convergence, like the terrestrial and non-terrestrial or satellite networks. We also had the keynote speakers. Satiji mentioned about some key challenges, rules of the standardization bodies. Madeline gave a very in-depth overview of the broadcasting standard of ATC 3.0, another area of convergence like broadcast broadband convergence. We also discussed about devices, spectrum, sustainability, and all those things. So uh, here again, a few things come to my mind. Like we are talking of the future and lot of things to be done. Very promising technologies and new services or use cases are visible, are being planned. So at the same time, there is a very important role for the standardization bodies like TSDSI and TEC and all the experts available in this panel, and also those who are listening, or all others, to start thinking and see how we can contribute. One of the important aspects of standardization is that interoperability is there. We also have to see that the other important requirements such as affordability and sustainability are also there when we are moving ahead. So these are some of the few thoughts, and I think we are already running very late. So I will not take much of the time, but I would definitely like to thank the organizers, TSDSI, for this wonderful event, and also thank the very eminent panelists and the chair and the convener for these excellent thoughts, and also all the uh, audience who have been here for so long. I think, thank you.
Thank you, Avinash ji. And now I just wanted to. So this is the time for giving you appreciation to all the speakers here who have done a wonderful job. Thank you, everybody. It's been a long day. I appreciate your dedication in putting together the material and giving your thoughts in such a lucid way. Thank you, and have a good day. That's the end of the session. Thank you.
Thank you.